Okay, so in this episode, what we are going to do is talk about integers and what's the difference between an integer and a natural number, and how do they compare, and just what are they exactly. So I'm not going to do a standard intro or outro. I'm just going to jump right into it. Okay, so if we remember on the very first episode, we talked about all of our natural numbers, which were your numbers from 1 all the way to 5, all the way to 100, and all the way to 1000, and all the way to infinity. And we put these natural numbers in a box. Then the next thing we had were all integers, and all of our integers, it's a terrible way of drawing it, but it's like the Z looking symbol, and in the middle we had 0, and then we had 1, 2, and then all the way to infinity, all these numbers. Now the difference between a natural number and all integers are the negative numbers. So then we had our -1, -2, -3, and then all the way to negative infinity. And then when we look at this box, we drew our integers, and then we had our natural numbers inside. So if we look at this number line, or we look at the natural numbers and we look at all integers, we can see that all of our natural numbers are inside of integers, but not all integers are part of natural numbers. And this box kind of represents it here. So now I want to show you something else with natural numbers. I'm sorry, all integers that you will see sometime in the future, if not already seeing it, is you will have a letter such as A, -A. Now don't worry, and sometimes you'll have B. Don't worry that this is a letter of the alphabet, or B, a letter of the alphabet. This is just a representation of some constant number that should be here. It's because we know there's a number here, we just don't know what it is, but we want something there to represent all numbers. In this case, all integers. So again, don't get nervous about A. It doesn't matter what this is. It could be a smiley face, a negative smiley face, or it could be a negative confused face, or it could be a negative squiggly line going everywhere. That's still going to be less than 0. That's less than 0. The squiggly line is less than 0. Again, this A, the reason why we use this A is someone a long time ago established this as a representation of some number. The same thing with B. It doesn't matter. It could be smiley face, or it could be that, or some squiggly random weird line going everywhere. It doesn't matter again. So don't worry about this now that letters are being introduced into mathematics. All it is just a representation to show that there is a number there. We just are not defining this number just yet. We want to focus on the idea that some negative number is less than 0, and some positive number is going to be greater than 0. That's all that means. In this case, let's say that we have -1. Let's just say we'll say A is 1, and that is less than 0. And B, we'll say B is 2, and 2 is greater than 0. So now that we went over a little bit further in depth of all integers, and we reviewed natural numbers and all integers. Let's just focus a little bit more directly with all integers. So with our all integers, we know we have 0, and 0 is greater than some negative number, and 0 is less than some positive number. And again, don't worry that these are alphabets now involved with mathematics. It's just a representation that someone made up a long time ago to keep track of what we're working with. So now we know that 0 is less than 1, 1 is less than 2, 2 is less than 3, and then let's say -1 is less than 0, -2 is less than -1, and we could say -3 is less than -2. But what does that actually mean? What does -1 being less than 0, what does that mean? Because if we have something like what we did in our the second and third episodes, where we had a room with chairs, and we filled the room up that was empty, had 0 chairs, meaning no chairs, and we put 1, 2, 3, 4, 5, 6, 7 chairs in that room, and in our third episode we removed all those chairs and we had no more chairs in there, leaving 0 chairs. If there's 0 chairs in that room, how can we have -1 chair in there, or -2 chairs, or -3? Well, in a situation like that, it doesn't make sense, because we can't have negative chairs, or we can't have -2 chairs, or -3 chairs. Ideally, we can't have that. But let's just say that you are having a party in your house and you need chairs. Let's just say in that room you were supposed to put let's say 5 chairs in that room. Well, then all you have though are 4 chairs. So if we look at this in a subtraction form, well, previously we only worked with natural numbers, so we couldn't subtract 5 from 4. But now that we have opened up a whole new world with all integers and we are working with our negative numbers, now we can. So if we turn this around and we said we have 5 minus 4, meaning we have 5 chairs and we are getting rid of 4 chairs. And we can break this down again like we did previously and decompose 5. Well, we know 5 is greater than 4, so we have a 4. Then what plus 4 makes 5? 1. So then if we take over here our 4 and we minus, then this will cancel out, this will cancel out, and that leaves us 1. But in this situation, we can't subtract 5 from 4 unless we use all integers. Now, if we do the same thing, we can decompose, but these are negative, remember? So let's just say we have, this is a minus sign, so we have -4, and then we have a -1. And then over here, let me draw arrows so it's more distinct. We have 4. And 4 minus 4 is 0. That just leaves a -1. So -1. So we had 4 chairs. We were supposed to have 5 chairs. And now, because we don't have 5 chairs, we only had 4 chairs, we are missing 1 chair. That's one way to look at it. Okay, so that's it for this episode. Today what we did was reviewed all natural numbers. We went over all integers. We introduced the less than symbol, the greater than symbol. We introduced a and b as some constants, some number that we don't know. We just are using a and b as a representation of some number because we don't want to specifically say -1, -2, -3, -1,000,000, 100, 2,000, 4,000. We don't want to use that. We just want to show you or represent some number. And for that, we are using the letters A and B. Don't worry that these are A and B. It's just somewhere somebody a long time ago decided that A and B are going to be standard letters that we'll use to represent numbers. Another way to show this is that some number, some negative number, is less than 0. Some positive number is greater than 0. Don't get scared that this is an A. Don't get nervous that this is a B. Again, it could be a happy face, it could be a house, squiggly line, it could be a tornado, a chipmunk, it could be anything. It's just we're using A and B as a standard universal way through all mathematics to represent some number. So that's it for now. In the next episode, I will go over in more detail all integers involving addition and subtraction. And I'll try to come up with some more real-world applications to make sense of it all. Something better than what I did in the last section where I used negative chairs. We'll go maybe use temperature. We are all familiar with negative temperatures, or maybe freshmen's college freshmen's bank account can reach negative numbers. And but that's it. I hope this gave a little bit more clarity in exactly what all integers are. And if you have any questions, email me or message me or leave a comment, and maybe I can do a follow-up video to help explain maybe in a different way of what all integers means. And until the next episode, I hope what I went through with all integers and natural numbers, I hoped it helped bring or lessen your math anxiety involving all integers and what exactly they are. And I hope it brought some understanding to you that actually made you feel like, in fact, that you are a math person.